we need to be able to convert Cartesian form into polar form and to be able to do polar back to Cartesian. So we'll just look at an example of going from Cartesian to polar. So we had a complex number z equals -1 plus root 3i. And we want to express that in the form of r theta. So this is my x and this is my y. And I think one of the best ways of looking at this is to actually do a quick little sketch of this complex number on the Argand plane. So we've got the real, we've got our imaginary axes. Now it's -1 and root 3. So there's my complex number z, and I know that this is r, the length from there to there is r, and I know that this is theta. Theta, don't forget, goes anti-clockwise, starts at the positive real axis and goes around there. So I've got to find r and I've got to find theta. So what we've done previously is we know that r is equal to the mod of z, and that's equal to the square root of x squared plus y squared. Now in this instance here, my x is -1 and my y is root 3. So that'll be equal to the square root of, and -1 squared is 1 plus root 3 all squared is just 3. So that's root 4, which is equal to 2. So I've got r equals 2. So I know the length from there to there will be equal to 2. So I've got the first part of the polar form. Now I've got to find theta. Now I think because it's a little bit tricky when we get into quadrants other than the first. So here we're in the second quadrant, and you can have complex numbers on the Argand diagram down here or down here. So I'm going to make this alpha, and I'm going to find alpha first, and that will make it very easy to work out what theta is, because I know that this out here, if I go all the way around there, that'll be pi radians, and up here is pi on 2. So I'm expecting theta to be somewhere between pi on 2 radians and pi radians. Alright, so I've got that as 2, I know that's root 3, and from mathematics that you've done, and I'm sure from trig you've done, you know if that is 1 and up here is root 3, that this angle here, so if I look at that triangle there, I've actually flipped it around a little bit here, but I'm not going to be so much concerned that's a -1. I know that's 1 unit from there to there, and we get out to -1, and this is root 3 up here. I'm going to find alpha. So here's my alpha here, and alpha will be the angle that has a tan opposite over adjacent. So alpha equals the angle whose tan is root 3 on 1 opposite over adjacent. And from your magic triangles, 1, 2, root 3, you know that this is pi on 3 and this is pi on 6. In degrees, that's 60 degrees and that's 30 degrees, and that's a right angle there. So we're looking at this triangle here. We know that's 1 unit and that's root 3 unit. We've ignored the fact there was -1 there. We're just going to find out alpha. So alpha, the angle that has a tan of root 3 on 1 from our magic triangle is root 3 on 1 is pi on 3. So alpha is equal to pi on 3. Now that will allow us to work out what theta is. That's not what theta is, that's alpha. Alpha is this angle here. We want the angle from there all the way around to there. So my next line is theta, because if we go all the way around to there to pi, and then we come back alpha. Alpha we've just worked out from the line above is pi on 3. So theta is equal to pi minus pi on 3. To be able to calculate this, we need to make them both over 3. So if I multiply, pi is like pi on 1, multiply top and bottom by 3, we get 3 pi on 3 minus pi on 3. So we get 2 pi on 3. So that's our angle theta. So now I can express in polar form. So minus 1 plus root 3i in Cartesian form can be expressed as r theta. R, picking up above here, r is equal to 2, comma, 2 pi on 3. In this case, it was one of our magic triangles that we were able to work out without a calculator. If you didn't have, if it wasn't one of the magic triangles, you would just have to use the inverse tan button on a calculator and put the opposite over the adjacent, work out the angle, and then take it away from pi. And that will give you the angle theta. So it's a technique that I think, as long as you draw a diagram, it's easy to see exactly what's going on. It is easy to predict exactly between what two values theta is going to be. It's going to be between pi on 2 and pi. We know it's somewhere in between, in this quadrant here. And so you know that 2 pi on 3 certainly lies between pi on 2 and pi. And r is the easy part to work out. It's simply just the modulus of z, which is the square root of x squared plus y squared. So there's my Cartesian form expressed in polar form.